Welcome to Unlayered, the show where we explore next-gen blockchains. I'm your host, Saul, alongside special co-host Zen Llama, and here we're in another episode of our more technical series. This time we're speaking with Piers Ridyard, CEO of Radix. Their website's radixdlt.com. We'll have that in the show notes. And it is a very interesting architecture that Radix has built for their protocol, powering Web3 and DeFi applications. We're going to get into how that all works and how it's different and why it's interesting from a technical standpoint and fits into our theme of being a next-gen blockchain. But before we get into that, Piers, thank you so much for joining us. This is an episode we've been wanting to make happen for a long time, and happy to finally make it a real thing.
Yeah, thank you very much for having me on the show, and shout out to Avant from our community who has tirelessly made sure that this happens.
Absolutely. I guess let's start really simple here. How would you describe what Radix is?
Yeah, I think there's sort of many layers to this. So let's start off with the highest level possible. Radix is a layer 1 protocol. So it's a public decentralized ledger focusing specifically on decentralized finance and Web3. And the three things that we really solve for the sort of DeFi and Web3 space is scalability, usability from a developer point of view, so developer experience, especially from the point of view of making it really accessible for new developers coming into the space to be able to easily build DeFi applications and DeFi front ends, and usability from an end user point of view. And this is specifically thinking about how do you make it accessible for a mass market to be able to easily come on and use Web3 and DeFi directly via a non-custodial wallet, and what needs to be true for that. So thinking about things like making it really easy to onboard, getting rid of seed phrases, making it really easy to understand, so making it so that your transactions that you do are human readable, so no such thing as blind signing. Make it really hard to mess up, so things like man-in-the-middle attacks, signature manipulation attacks, sort of like fake front-end attacks where you sort of get token permissions to be able to drain funds, just make that impossible to do on top of the Radix network. And make it really easy to do the thing that actually we think matters the most from a user experience point of view, which is connecting to DeFi applications and DeFi and Web3 applications. What I mean by that is most wallets are built around this concept that my wallet is, the main thing I use my wallet for is holding my tokens. I actually think that's the smallest percentage part of what a wallet is actually for. What a wallet is it's your access, it's your window into Web3 and DeFi usability, into Web3 and Web3 DApp usage. So really the key thing about your wallet is about connection and permission, so that you can actually use Web3 and DeFi natively. And so we can move these hundreds of millions of users that are currently in these weird walled gardens that we called exchanges and actually get them using Web3 and DeFi native. So those are the three things that Radix focuses on, and that's what the stack is all about. Is great usability from a user point of view, great developer experience from a developer point of view, and sufficient scalability to be able to go mainstream with crypto.
So you touched on a few really interesting value props there. I think what stood out most was making it hard to mess up and kind of reducing the surface area for potential exploits and attacks.
Right.
Because I think a lot of us, it's almost a rite of passage in crypto where you've fallen for, a grift, you've signed the wrong transaction, maybe you've gotten phished.
Right.
To say that it's possible to, at the protocol level, make that not a thing.
Yeah.
I guess my question is, how does that work? How are you able to do that?
Yeah, so it's there's sort of many layers to this answer. So I'll drop one level down and sort of give conceptual answers here, and then we can drop again down to sort of more technical specifics if you want to. So the starting point for this was we realized that there was a problem in how crypto, specifically DeFi, was being built in 2019. And in 2019, we took the strategic decision that we were going to focus on decentralized finance as the main thing that we thought was going to be the value prop for public ledgers. That was going to be the main way in which finance and eventually sort of the entire GDP of nations is going to move on top of public ledger. So finance was going to be the enabling factor for that. And DeFi was only just emerging, like Aave had recently changed from ETHLend. MakerDAO and DAI was the main game in town, and it was actually the DAI savings rate that started the trend for DeFi. People don't remember this, but the DAI savings rate was 5%, and at the time the yield on the yield on treasuries was like less than 1%, and people were like, wow, 5%, great, low yield environment, DeFi high yield environment at 5%, which seems crazy now. And we watched this industry start to emerge where people are trying to build autonomous marketplaces that were starting to deal with tens of millions and then hundreds of millions of dollars of cash. And then we were starting to see all these hacks and these exploits. And we went and interviewed the DeFi developers and the DeFi projects at the time to understand what were their main problems that they were facing. And there was sort of three sets of problems. I'd call two of them business problems and one of them specifically a developer problem. The developer problem was that a developer was typically spending about 80 to 90% of their time when building a DeFi app on security. So about 10% of their time was on functionality. How do I get it to do the thing I do? And then 80 to 90% was how do I stop it from messing up? Yet despite this, you are still seeing hacks and exploits happening all of the time. Sort of common issues like unsafe reentrancy or signature manipulation or permissions escalations, like all of these kind of things happening over and over again. And so we sort of dived into, well, what's a developer spending most of their time doing? And what it turned out is there was a bunch of patterns that emerged from that. Now, and a lot of these patterns were based on low-level primitives that developers were having to rebuild every time. A simple example of this is when you build a token in Ethereum land, you don't just say, hey to the ledger, hey, I want a token. You actually have to create a contract that defines what it means to be a token, what it means to be able to transfer a token, and all of the balances of that token. And then you have these standardized interfaces, which is actually what the ERC20 standard is, to be able to sort of delegate permissions, to be able to update balances and all this kind of stuff. And all of these hacks were coming from things like sort of like permissions escalations or permissions delegation, like unlimited permissions, all of this kind of stuff. And the complexity of how you architected when the ledger didn't understand what a token was, and you had Uniswap now having to actually just coordinate messaging between multiple different balance holding smart contracts to be able to facilitate a swap. And the architecture of the smart contracts, when you looked at it, when you actually drew it out, looked nothing like what you'd expect if you came to someone and said, hey, I want you to build a swapping application that's swapping tokens, and they drew the architecture, and then you showed them what it looks like in Ethereum land, they'd be like, that's mad. So this is where all this complexity was coming from. So we took a page out of the game industry's playbook. When the computer game industry was first getting started, you had to be a god-tier developer to be able to build a computer game, right? That's why people like John Carmack were considered this like prodigious developer, because he was able to develop all the way up and down the stack. He understood low-level implementation, the creation of rendering engines, the creation of physics engines, and he also had a feel for art, and he had a flair for game design and was able to build the high-level stuff as well. But most people were not that level. And so the games industry was relatively cottage industry. The thing that changed the game for the game industry was the games engine, so Unity and Unreal. And what they did is they standardized the way in which you built games, and they standardized the format, the components that you could use to build games. So they gave you a standardized rendering engine, standardized physics engine. They did all of the low-level implementation on a per-platform basis. And they also created modularization of the components that you could use to build a game. What that did is it lowered the barrier to entry for new developers to come in and build in the games industry, but it also meant that you had a standardized set of tools. So if you built in Unreal, then you could go and work in any games company that was using the Unreal Engine, and you could go straight into it. The maintainability was much higher. And so then you had this ability to build more and more complicated games as a result of these modular, standardized underlying components. And that's essentially what we did with Radix. We created what we call the Radix engine. And in Ethereum land, you have the EVM. In the Radix land, you have the Radix engine. And the Radix engine is both the execution environment, but it also has a bunch of enshrined components into it. So we've pushed a bunch of the high-level concepts that you have to implement in Ethereum land as a developer, and we pushed them down into enshrined components within the Radix engine. So you can kind of think of these as, I sometimes describe them as like asset coprocessors beside a CPU. Like enshrined objects is like what Vitalik talks about. And the key enshrined objects are tokens are enshrined objects, NFTs are enshrined objects, accounts are enshrined objects, the permission stack is an enshrined object. And then the concept of asset handling is actually, so asset transactions, asset transfers are actually handled by the ledger itself. So when you create a token on Radix, that token is a native object of the ledger, and the balance maintenance is actually done by the ledger itself. So if I transfer, from my wallet to your wallet, I'm actually transferring from my wallet to your wallet. I'm not updating a balance on a smart contract. That is a ledger-controlled object. But the best way of thinking about this is actually that each of these are frameworks for the issuance of resources or the use for resources. So we don't just say, this is the ERC20 standard in Radix, or this is the ERC721 standard in Radix. We say, here's a framework for the issuance of NFT type objects. And within this, you have the ability to change your metadata. You have the ability to specify, how the object looks on Ledger and what the attributes of it are. But it's within a standardized framework for doing that. And for tokens, it's the same. You can essentially think of that you have flags for the tokens. So you go, I want a token. I want this object on the Ledger to be a multi-issuance object. I want the right for that multi-issuance object to be controlled by the permission stack, right? And I want this, account to be the first one that has the right to do new issuances of it. I want it to have, I want it to be recallable. I want it to be freezable. Let's say that you're issuing a stable coin. And then I specify that against the standardized framework for the creation of tokens. And now I've created essentially a recallable, freezable, multi-mint token. But that's a native object of the ledger. And the thing that then happens is those flags, that metadata, actually flow all the way up into the user experience. So if I sent you that token into your wallet, immediately it would appear. It didn't matter if I created it 5 minutes ago, it would appear. It's a native object of the ledger. So your wallet didn't have to know to look up this, custom contract address for you to be able to see the Piers, multi-issuance token. But importantly, in your wallet, you would also see under the description of the token, or as underneath the metadata, and very visible is, oh, this is a recallable token. This is a freezable token type. This is a multi-issuance token type. So there is no ability to create a token that pretends to be one thing, but actually has something hidden within the asset rules, within the smart contract, that actually means it's something else, right? And the important thing around these native objects is now the way in which you pass authorization in transactions becomes much simpler. This is how we get human readable transactions, because you have this ability to go, I'm not giving this smart contract, let's say a swapping smart contract, the permission on my behalf to update my balance in this other smart contract that's maintaining balances, which is what happens in Ethereum land. On Radix, you're going, I am in the transaction, and we can talk about the transaction layer in a little bit more detail because it is very cool. It's a fully programmable transaction layer, which allows you to specify, to basically compose together many, many different objects all in the same transaction and many, many different interactions with applications all atomically. But just very simply here, in the transaction layer, you're specifying, you're saying, hey, I'm taking 10 Piers tokens out of my wallet. I'm interacting with this application. Now, this application only has the right to deal with these 10 tokens. It can't deal with anything to do with my wallet because that's not part of what I'm actually giving it permission to do. I'm passing over these 10 tokens. Then I expect to get back from this smart contract, I expect to get back at least 20, unlayered podcast tokens. And those guarantees are set at the ledger level. So you actually have the invariance in the ledger level, so that the smart contract, even the smart contract was a fake smart contract and it actually didn't do anything. It was just trying to drain Piers tokens from me. It wouldn't execute at consensus time. It wouldn't execute the network wouldn't actually execute it because you're not adhering to the rules that have been put by the user into the transaction itself. So if it doesn't return you 20 tokens in that transaction, it fails. And you can change that to be like, 18 tokens if you're happy to take some slippage or whatever. But that invariance is actually at the user level. And it's, again, completely visible within the wallet. And so that gives a bunch of what we call basically guardrails for the user. But it also gives a bunch of guardrails for the developer. So by having these native objects, by having a enshrined permission stack, things like unsafe reentrancy is not possible in Radix. Things like mistaken asset handling is much, much more difficult. So Scripto itself is a programming language based on Rust. This is our programming language. So in Ethereum land, it's Solidity. In Radix land, it's Scripto. That programming language fundamentally understands the concept of assets. Assets are a primary, or what we call resources, are a primary object of the ledger, and all of the things, all of the functionality, the enshrined feature set of the Radix engine, essentially is used within the Scripto programming language. So all of the low-level things you need to worry about in terms of like, have I correctly sent these tokens, and what happens to the change? Like, what happens if I've got a return? All of those things are basically dealt with by the ledger and by the Radix engine itself. Things like reentrancy are dealt with. We have safe reentrancy rather than unsafe reentrancy, which is dealt with by the permissions system, which essentially gives you an ephemeral token at transaction time for one-time reentrancy or whatever. Like these things are all dealt with so that you can't. It's much harder to mess up, and this is where the guardrails for developers comes in. The programming language understands the concept of assets. It has a bunch of enshrined tools which abstract away a lot of the hard, low-level stuff that the programmer has to worry about. And the compiler actually understands safe asset handling. So if you've done something like stupid in how you've handled assets in your program, it won't even compile. And so by the time you get to compilation, you're about 95% of the way there. You may have made some business logic errors, but you're not going to have made some fundamental errors associated with asset handling. And all of that results in these claims that we're making about it being much safer for a user, much safer from a developer point of view.
So if I can follow up here, it sounds somewhat like it's somewhere between Move and Solana in the sense that like Move has it understands like object types right natively at the bytecode level, and then Solana has like the SPL program library where it has like the concept of standardized logic that you can call into to do certain things.
Yep.
Maybe you could compare and contrast both of them and how it's like slightly different or
Sure.
somewhat the same.
Yeah. So was the library in Solana previously called Anchor, or is what you're mentioning something different?
So Anchor is a framework, but the SPL library is like a standardized program set. Now it's not enshrined, but it is it's almost like a precompile.
Right. Okay.
In the EVM. So it is like a program, right? That's not in a smart contract that has like defined logic. But yeah.
Yeah. So obviously, making it enshrined into the ledger has a bunch of benefits to do that are relatively multifaceted. I mean, the simplest one to point to is performance. You end up because the Radix engine enshrined objects are much more performant to execute. You end up getting a huge performance difference when you're looking at sort of DeFi throughput. So a simple example of that is if you take the example I always take is the Dragonfly benchmarking that they did of different ledgers, where they went, okay, there's the advertised throughput, 65,000 transactions per second for Solana, but how many DEX swaps per second can you do on Orca? And they came back with a benchmark of 275 DEX swaps per second as the maximum throughput. And part of this is because of how the logic associated with the swapping mechanics is architected and then executed, and how that actually has to run through at execution time. With the Radix engine, because you're dealing with enshrined objects that are executing sort of as highly performant to the ledger itself, we get a 80% efficiency. That means that if our advertised throughput is 1,000 transactions per second, we should be seeing about 800 DEX swaps per second. And the reason that matters to us, or what we think it matters in DeFi in general, is that the majority of transactions that are happening on public ledgers are not transactions of one account to another. They are interactions with smart contracts, and the majority of those are some form of swapping or exchange. So this enshrinement gives you a huge amount of performance versus having it as sort of a pre-compile or a program on top of the ledger. Going deeper into that, I don't know how. In Solana's example, I don't know specifically what are part of that pre-compile or not, so I couldn't really compare it to accounts. I mean, for example, on Solana, are smart accounts a native object, or do I have to do the same thing that I have to do with abstracted accounts in Ethereum to get an abstracted account?
It's kind of both. So like the accounts are kind of dumb, and then you can like delegate to like another account. So it has native like delegation to a smart contract that could be a smart account, but the like accounts as a primitive or just accounts.
Got it. In an account by default a public-private key pair? Is it an EOA address, or is it something else?
So they're all public-private key pairs. Yeah, and some of them are like data accounts, and some of them are like program accounts, and then you can like pass data into program accounts.
Right. So let's compare and contrast that to Radix.
Yeah.
On Radix, we have no EOA addresses. You cannot have anything sent to a public key. Everything on Radix is a smart contract account. And accounts are enshrined object as smart contract accounts with specific functionality. So, for example, when I create the account object, and I associate a public key to that as the first authorization for that account. But I can then add from that point forwards multiple public keys. So I can have decentralized recovery. I can have multi-sig. I can have all of those things just off the bat. And that means I can lose my phone, lose my keys. This is why we're able to have seed phrase free onboarding, because you can get to this point very quickly where you can take someone through a user flow where they set up their account and then they immediately set up a recovery factor. And now they don't actually need their seed phrase because they've got their recovery factor. And you can have recovery factors. We have a whole rule set around recovery, which is sort of actually very robust. And we've extensively tested over a 2-year period on getting normies, everyday people using there. But then that account primitive, because it's standardized, every single interaction with a smart contract or every single interaction with a user follows the same pattern. So there is no confusion as to, I have to support multiple different ways in which people have chosen to implement accounted accounts, delegated authorities, all of this kind of stuff. Like, there is just the Radix account type. You support that, you support every single account on Radix, but there is no such thing as EOAs. So you're always interacting with smart contracts. Then there's a more complicated functionality you can add to like that, like where you can have like, what's it called? We have a specific term for it, allowances. So you can say, then you can do things like, I want to have regular payments off this, and there's an allowance on that. Or I'm playing a hand of poker and I don't want to have to authorize every time I'm betting chips. Like, all of those kind of things can be done. Again, smart contracts, smart accounts allow that to happen. And that only really happens when you have it as an enshrined object. And the other thing that is like really boring, I get really excited about, but not many people get excited about, is this sort of like enshrined permission stack. Like, permissions are just everywhere in smart contracts and in interactions with Web3 and DeFi. And also you see it in finance all of the time, where, you might have in finance called a 4 eyes process, where you have, sort of like the initiator, the verifier, and the signer, which is a 6 eyes process, where you have a specific set of people who are allowed to do one thing, and it could be 1 of 6 of that, and then a specific set of people that are allowed to do the next thing, and it could be 2 or 3 of that, and then a specific set of people who can do the last thing. But you might need to have certain rules where you go, well, if it's up to $100,000, then it has to be this set of people, but if it's over $1 million, then it has to be 2 of 3 of these. Those all can be modeled directly on Ledger using the native permission stack, including then things about sort of cross-ledger calls between accounts or smart contracts, where you're like, I want to allow this set of smart contracts to be able to call this particular function, but this set of smart contracts can only call this particular. Again, all of that's done by the stack. That standardization of the permissioning rules over time creates this immense degree of operational security because there's a familiarization with everyone who comes in and uses it, which means that you know the right ways of configuring it. There is the correct pattern, a strongly opinionated pattern about how you should do correct security within this, but then that standardizes how you expect to be able to interact with another smart contract, or how you expect to be able to interact with the service. So again, those enshrined services make a much better play for development. And I think that the industry is kind of looking towards that. This is why Solana's going down this route with the library services you're talking about and the anchor as the framework, but Radix goes this whole hog of enshrining it truly into the ledger, which we were able to do because we launched later than other people. The move version is a really interesting one to compare and contrast, and it becomes a bit more abstract around how you think about objects and logic. So we have this concept in Radix where we talk around business objects and business actions. And the whole pattern in crypto right now is I've got an object and I'm going to put the business logic associated with the handling of that object into the object. So I've got an NFT and I want to have some logic associated with how the NFT is allowed to be transferred, who's allowed to own it. And I put all of the logic into the object. And this is the route that sort of Move and Sui have gone down, where objects essentially contain the logic associated with those objects as well. On Radix, we've taken a very specific path where we've said there are objects and then there are rule sets associated with objects, and the two things are separated. And they're separated for a large number of reasons. One is that you may want to update the rule set associated with an object, but you don't want to update the object itself. The other is that by separating those two, you can have standardized objects that are understood by applications and wallets and all this kind of thing within the ledger natively. But by pushing the business logic into it, suddenly the behavior of those can become entirely unpredictable. So on Radix, you have the enshrined resources, which are the objects, and then you have the ability to add business logic to things like transfer rules and ownership rules and all that kind of stuff at the scripto programming level. But it's this key separation between there's the Radix engine with the enshrined low-level primitives, and then there's the programming language that's responsible for defining business logic. And Radix is the only place that actually separates those two things as two levels of abstraction rather than one. Everyone else just pushes everything into one level of abstraction, which is the programming language, which then breaks your standardization framework for creating good user patterns for building things, because suddenly you've got this much more open environment for defining whatever user pattern you want, but then that breaks the standardization that makes it easy to be able to build things in the first place. And that's what we think is the fundamental mistake that Move has made.
Awesome. So we've delved quite deeply into the developer experience, and that comes mostly from the VM, right? The Radix engine. I would like to explore a little bit more about the architecture on the other side. So consensus as well as the database. If we can maybe get into that a little bit, I think what really was kind of differentiating for Radix when I came across and looked at it as an architecture was this concept of shard space.
Yeah.
Right. So Radix, unlike Solana, right? Solana is maybe the most monolithic version of a blockchain that you can get, or integrated version of a blockchain that you can get. Whereas Radix is going the completely opposite way. And so they've literally done this thing where they split up all of state space into something called shard space.
Yeah.
And so maybe we can go into what that means and just conceptually what that's like.
Sure. Yeah, for sure. I think before I dive into it, just as sort of an orientation for the listeners, the first version of the Radix network is live today. As of the 28th of September last year, it went live. The current version of the Radix network is not sharded. It's a single sharded instance that has the Radix engine, the scripto programming language, the Radix UI, UX environment, and the Radix wallet. That's all live. and it's all been architected with respect to what I'm going to be talking about now in terms of the fully sharded end state. So everything that we've built from the UI down is already architected for sharding, but the first version is not sharded. So I want to premise that up front so that people don't think that we're already sharded, which we're not. So the starting point of the Radix consensus, which is called Cerberus, was, I think, some relatively, when I say them, they're relatively obvious insights, but I think that they were really important insights. The first is that if you have two unrelated transactions occurring, there is no reason to order them against each other. That's the first step. The second step is saying, can the data layer itself help you help consensus separate between things that are related and things that are unrelated? So the thinking was, you can't linearly scale any vertically scalable infrastructure. You have to horizontally scale at some point. You can't infinitely vertically scale. You always have an upper limit to that. So at some point you have to horizontally scale. You have to be able to add more computing horizontally to a system to be able to scale its throughput infinitely. So if that's the case, then sharding is kind of an inevitability in one form or another. Now, if you take sharding to the extreme, if you say that the entire world is using the public ledger, and for the entire world to be using a public ledger and to be, taking the bandwidths and storage requirements of the internet into account, how many shards would be necessary for an average computer, an average server that I'd find at AWS, to be able to be part of processing that? You're probably looking at millions of shards, if not more. Okay, so let's run a simple thought experiment here. If I have millions of shards on a public ledger, what is the probability that any given transaction is going to be to another account on the same shard I'm on versus on a different shard? Well, your probability is basically 1 over the number of shards that you. So if I've got millions of shards, say I've got 10 million shards, there's a 1 in 10 million chance that a transaction is actually going to be happening, that I'm doing is going to be happening on the same shard. Most transactions, therefore, in our future world where bandwidth requirements and storage requirements and usage requirements and throughput requirements require there to be a huge amount of sharding, most transactions are going to be cross-shard. Okay, if that's true, then actually your problem isn't single-sharded consensus. Your problem is cross-sharded consensus. Your constraint is always going to be the coordination between shards.
Yes.
Not actually the throughput of any given shard. That's what we're caring about right now as an industry. Solana is a great example of that. But so's Avalanche, and so's all of these other ones where they're going, our maximum throughput on a network is 3,000 transactions per second. Sure, but your problem is actually this cross-chain component. So those were the key insights. So the outcome of that is, okay, well, to actually create linear scalability within a multi-sharded, within a highly sharded environment, you have to develop a cross-chain consensus algorithm, a cross-shard consensus algorithm. And ideally, that cross-shard consensus algorithm has to have the feature of atomicity. So you have to be able to have all shards agree to an update, a state update simultaneously, or it to fail. Because if you don't do that, if you can't have atomicity, what you end up in this problem is intermediate state. So if I'm swapping from, just to put this for the reader's point of view, I can see that you get it, Kevin, but if I want to do a trade between Arbitrum and Optimism, where I'm borrowing from Arbitrum, trading on Optimism, and then repaying a loan on Arbitrum, I have to first borrow on Arbitrum, complete the loan, move my assets across, try and complete a trade on Optimism, and then go back and repay the loan. but I may have taken the loan out without the opportunity still being there. So what I'm left is this intermediate state. I didn't actually want the loan at all. I wanted the loan if I could get the trade, but if I can't get the trade, then I don't want the loan. But I've ended up in an intermediate state, and you can actually get in much more complicated, problematic intermediate states. And the basic point is, if you don't have atomic cross-shard composability, you also end up in these problems of rollback states, which in consensus is a nightmare. So you always want to avoid. So
and if I could jump in right there, because I think this is a really important point. Conceptually, I think this is why the monolithic chains, like as so far, have made sense, right?
Yeah.
Because they look at this problem of cross-shard composability. If you think of shards as, logical shards like L2s, and it's just a no-go for user experience in most cases. This exact problem you're talking about, right? There's like efforts to solve this through intents and stuff that like coordinate things, but it's a very complex problem. And so I just wanted to double click on the point you're pointing out here, is that like cross-shard communication, right, is the entire reason Solana is an integrated chain. So I'll let you continue, but I just wanted to double click on
fine.
that. Yeah.
And like this is sort of the DNA. This is the early DNA of Radix. Radix was founded by Dan Hughes back in 2013 as his as sort of a research project spun out of his work in Bitcoin, or it's like his sort of like, he got involved in the Bitcoin community in 2012, realized that Bitcoin's approach wasn't going to scale, and sort of went from there to be like, I think I could knock something up in 6 months. And then 7 years later, got to the point that, this is that we've published consensus at the Cerberus, our consensus algorithm in, sort of computer science journal, worked with the University of California, Davis to verify our sort of maths and theory behind this. But it's been a very long journey to now, and it's exactly that problem you just double clicked on. So, going back to this sort of like starting point of going, well, if you have to have a massively sharded network, then just lean into it. Just go, let's have a shard space that we never have to change. So let's have a shard space that is incredibly big. So the shard space for this system is 2 to the power 256 shards. And
so to put that in scale for people, that's like more atoms that are in the universe.
Yeah,
it's like
that's right.
A massive number.
Yeah. So I think I did a calculation when it used to be 2 to the power 128. I think it used to be. It's now 2 to the power 256. It's something to do with the hashing algorithm. But the 2 to the power 128 was if you took all of the data that humankind has and you dropped it into digital data and you dropped it into that shard space, you'd end up with like 2 bits per shard or something like that. So it's an astronomically large shard space. And then what you do is you then deterministically map your state data to that shard space. So I'm going to take it's not actually specifically accurate, but I'm going to take a simple example that makes it easy to conceptualize this. Imagine that we just mapped accounts to shards. So I create an account, and that account is on shard 5. And you create an account, and that account is on shard 10. If I send a transaction from my wallet, I'm going to be sending cross-shard. Say I'm sending to my mother, right? And you send in a transaction from your wallet, you're sending to your mother. We don't have the same mothers, we're not the same people, they're not coming from the same place. So now you already have this idea that I can see when things are unrelated, but I can also see when things are related. A double spend will always have to come from my account. It's always going to have a double spend from my account will always come from shard 5, right? And a double spend from your account will always come from shard 20. So you now have this very nice feature that by deterministically mapping your state to your shards, you're actually helping consensus along. You're going, well, conflicting state is going to be happening from the same shards, unconflicting state, or potentially unconflicting state, because it's not always unconflicting, right? We could both be trying to trade on the same DEX, for example, but like potentially unconflicting state is going to be coming from different shards. This allows you then to move to the next stage, which is parallelization. You can say, look, I can now run the system essentially embarrassingly parallel. I can go, if I don't care that when the my confirmations for these things start or end, if any validator is validating these shards, then all the validators have to do is come to an agreement that this transaction was valid, but they don't have to come to agreement that this transaction was valid and the time frame versus another transaction. So your transaction and my transaction can both be confirmed simultaneously. So you get these virtual consensus instances where basically consensus on any given transaction can start or end when it needs to, rather than having to order it monotonically against each other for the entire.
So these are unrelated transactions you're talking
these are
about.
unrelated transactions.
Yeah. Okay.
So now you get into the stage of related transactions. So how does the network know what are related transactions? This is where, really importantly, the transaction manifest and the transaction layer of the Radix network becomes really important, because in the transaction manifest, what you do is you declare your transactional intent, and you declare what state you're operating on, and you declare what applications you're interacting with. Right? And so that allows consensus it basically informs consensus what it needs to be concerned about from the point of view of coordination across shards. And so you have a cross-shard consensus mechanism called Cerberus, and what the cross-shard consensus mechanism called Cerberus basically does is it's a three-phase commit, which allows it to bring in validators on multiple shards to come to an agreement, an atomic agreement together on the state update of multiple shards. So it'll go, okay, I've got 5 different validator sets on, over 10 different shards for a complex DeFi transaction. And these all need to agree on their local state and on their cross state. And the Cerberus consensus mechanism is specifically the algorithm that is run to enable the nodes to go, do I think this is valid locally? I'm not going to commit to it yet. I'm just going to say, do I think this is valid locally? Yes, I think it's valid locally. Okay, who are the other nodes that I need to talk to? Well, I know what state I'm dealing with. So as a result of that mapped to my known validator set. So I call out to those validators and I go, hey guys, I'm processing this transaction. They go, oh, we are too. Let's have a conversation about whether or not we think we're all locally valid. Yep, we're all locally valid. Okay, are we going to commit to making this atomically committed across the shards? Yes. Okay, we've all committed, and now we're going to commit to it locally as well. And that's essentially what Cerberus is doing. But the whole point is that everything is cross-shard. There is no such thing as a transaction that doesn't touch more than one shard, really, in that environment. So everything is a cross-shard operation. Everything runs around that cross-shard consensus. But because you can parallelize, and because the shard space is so big, unless you're explicitly declaring that things are connected, you can just run them in parallel, which allows you to have this massive throughput as a result.
So this brings me to a couple follow-on questions. So as I'm understanding it, and correct me if any of this is wrong, I'm going to try to summarize here. If you have shard space that's 2 to 256, my understanding is you probably have an address space, right? And so your
Correct.
validators,
Correct.
I assume, are like assigned to some segment of this address space that it's validating,
Correct.
right? And so then when you have transactions and accounts, right, it declares the address space it touches, and then it needs to go essentially like synchronize with the validators that are validating that address space.
Yes.
What that leads to, in my mind, is like, doesn't that mean that not all the nodes on the network are always seeing the same state? And when does that get synced back to the rest of the nodes, right?
Correct.
And how do you have Byzantine fault tolerance if it's only a small set of the network that is ever validating, right, some address space versus the full like consensus set?
So essentially your nodes are constantly churning between, so you have a pre-image resistant way in which you churn the validators. You have a randomization function for doing that, and the validators are basically constantly churning and resyncing on
their address. So there's rotating address space that they're validating all the
Rotating
time.
address space that they're validating.
So it's
all the
almost
time.
like a leader rotation, but instead of rotating leaders, you're rotating what they're
Yes.
actually validating. Okay.
Yes.
I have a bit of a kind of different question. Basically, what you're talking about at the protocol level, it enhances in some ways user experience, developer experience, security guarantees. Is there a trade-off you're making here by making these optimizations in terms of what developers are able to build concretely, like new standards like 404s on Ethereum and Solana, or even just what you could do with on-chain games and uh, like friend tech, for instance, right? Like, would these applications be possible to have been built in this kind of paradigm where you're kind of giving that a very opinionated view on how people can do things and move money around? How do you think about that?
Yeah, it's so the answer is absolutely. Like we ERC 404 has already been implemented on Radix, and it didn't require a standard. It didn't require a standard because of the enshrined objects of Radix. Like ERC 404, there's Avant, the guy who helped set up this podcast, has implemented it himself and implemented a token type called ice and water, which basically allows you to move between water tokens and ice NFTs, which fully implements ERC 404, and he basically did it in a weekend. And wallets automatically understand and are able to interact with those objects because they're using the enshrined objects of the ledger. There's no standard to go around and get everyone to agree to. And FriendTech, the same thing. Like all of these, we basically, to get to the Radix engine and Scripto, we spent 2 years and spoke to about 1,000 developers and projects and then spent another 2 years just realizing how long it's been now, testing it within our community, of constantly getting people to come to us. Before we enshrined it into the ledger, right, we had this 1.5 year period of building our developer ecosystem, where part of the things we did is every month we run challenges where we're like, build dexes in Scripto this month, build lending protocols in this month, build social applications, build all of this stuff. And part of it was going, can we break this model? Is there something we can't make that makes people that breaks some fundamental thing that people want to be able to do in crypto? And the answer has been, sort of, for the 99% of the cases, no. And for those small cases where we find an exception that actually results in a significant problem for market addressability, then you can just update the Radix engine. And the update to the Radix engine doesn't break any of the existing smart contracts. It just adds a functionality. It adds an extra element of functionality to the Radix engine that new applications can then use. And you've rolled that out for everyone immediately, right? You haven't had to get exchanges to agree to integrate this new standard type because they are integrated with the Radix engine. Like, by integrating the Radix network, you are integrating the Radix engine. So if you update the network state, you update all of your integrations, custody, exchanges, wallets, everything. So yeah, not only have we not come across things that people can't build, this undiscussed burden of new standard adoption within infrastructure just goes away as well.
So I guess, like, one thing I'll ask is, like, how are you thinking about, like, developer onboarding, right? Anytime you have, like, a new programming language, it's inherently, like, a hurdle to get over, right? We've seen that in the move ecosystems. We saw that in Solana in the early days. It was kind of amazing that Solana has even, like, gotten the developer adoption it has from the
Amazing.
EV. Yeah. And so, like, how do you think about that? Like, Monad, we've consciously made the decision to go with the EVM because developer onboarding is much easier that way, right? And so, like, how do you think about this, right? Like, how do you think about this as a philosophical question? Right?
So I'll start with the philosophical first, and then I'll go into, like, the practical, like, how do you actually onboard developers? Philosophically, like, are we in the first innings or the last innings of the game? Right? I look at, from all of the interviews that we did, and the size of the crypto space from a developer point of view, tiny. Like, the Electric Capital report is 25,000, 28,000 full-time Web3 developers. truth is, it's in terms of the people actually building in Web3 and DeFi, like most people, everyone knows everyone. And like, that's really difficult to get if you have got something more than like 2,000, 3,000 people who are like seriously involved in the community. The size of the developer market, the number of developers in the world today is 25 million. And if we believe that these public ledgers, the DeFi and Web3 is truly going to be an innovation as big as the internet, it absolutely makes sense that you build a programming language that is as accessible as possible, as secure as possible, and is as easy to pick up as possible for new developers coming into the space. This was one of the things that we really focused on in that sort of 1.5-2 year period that we spent building Scripto. Was we didn't actually start with going, what tech stack? We didn't go, oh, we're going to use WASM, or oh, we're going to use Rust, or oh, we're going to use whatever. We actually started with the docs first. This is how sort of like insane the process was. I mean, it makes perfect sense when you think about it from a product point of view, but like we started with the docs. We went, all right, new programming language. Let's just build the docs around this pretend programming language that we're going to call Scripto, and we built all the pseudocode. And we spent, I'd say, a good 6 months of just doing user interviews with new developers and existing Web3 and DeFi developers, and sitting them down with the docs for a couple of hours and talking through at the end of it whether or not they understood the approach. And it was only when we started to do that, and we do it for 2 hours, they go home, they wouldn't take the docs with them, and over the weekend they'd then send us and be like, hey, I think I've coded up Uniswap in your like programming language, does this look right? We'd be like, holy shit, that's it. Like, yes, that is. So now we're getting to the point where we're really getting through to people. So like, that's my philosophical view, is it's easy in the present to view something as inevitable because of what it feels like it has momentum behind it. But when you actually contextualize how little an impact Solidity has had in the wider adoption of people programming it, and the huge problems and pains it causes, the significant difficulty to hire good Solidity developers. Yes, you can pick up Solidity easily, but being good at it in a way that you're like, yeah, sure, I'll trust 10, 20, $100 million into that, really hard. Then you're like going down to a few hundred people maybe that are at that level, right? And going right back to the start of this conversation, I said, there were 3 problems we identified when we were talking with DeFi projects. One of them was developer focused, and 2 of them were business focused. The 2 business focused problems were, 1, I can't hire enough developers. Height of DeFi summer, talking to some of the leading projects in the space, we were like, what's your number 1 problem? We were expecting them to come back with scalability, hacks and exploits. They just went, we can't hire enough people. We can't hire enough good developers to be able to build what we actually need to. We got the users, we got the capital, we got the hype. We can't actually deliver product. And at the height of DeFi summer, when you've got the charts of the number of developers in Solidity going up, and you've got these projects that have got more money than they know what to do with, and they are saying, I can't hire developers for like love nor money. And at that time, people were throwing like $300,000, $400,000, $500,000 salaries at like people who'd done Solidity for 2 years. It was insane. That's what I look at when I go, that's why Scripto. And then incidentally, I may not get to it, so just to mention the number 2 problem was bounce rate. So the number of people who came and tried to use their application and then wasn't actually able to add money to it because they found the usability too hard of MetaMask or things like that. A lot of these projects, even at the height of DeFi summer, had a bounce rate of like 98%, which is insane. So that was the number 2 problem. And then those 3 things really define a lot of the trajectory of what we decided to build as tech. From the point of view, how do you onboard developers? I segment in my mind the developer market into 4 quadrants. And if you imagine an x-axis and a y-axis, right? So along the x-axis, you have level of developer experience, right? So how good as a developer are you? And 0, you've got like, a script kiddie, someone who's just learned Python for the first time or something like that. Not to disparage Python. Python's great. And I can't, I'm not particularly a programmer. I can't program. So like, but just someone who's just started picking up like Python. And then on the other end, you've got Linus Torvald, the creator of Linux. So 0 to 100. And on the y-axis, you've got level of DeFi understanding. And so at 0, you've got, let's say, I can't remember, Warren Buffett, right? Level of DeFi understanding 0. And then at the top, you've got Andre Cronje, like level of DeFi understanding 100. And then that creates your 4 quadrants. And your top right-hand quadrant is basically where all of your like top Solidity developers are. They are both very high level of DeFi understanding and very high level of competence, because they have to be able to be building the programs that can hold this much value. We ignore that segment. That segment, those guys are getting paid incredibly well and have a skill set that is incredibly valuable for that market. We're not going to go after those guys. Like, let all of the other projects, let all of the other ecosystems that are getting all of this funding go and duke it out for that tiny market. Fine. If you're EVM compatible, that's where you're fighting. Sorry. But then you've got sort of to the left of that, the people that we call the frustrated DeFi developers. They've got a high level of DeFi understanding. They're not quite at the level of like God tier developer to be able to be in that top right-hand quadrant. They've maybe built some stuff and it got hacked, or they thought about building it, but they felt like they would get hacked, so they didn't want to actually go in to do it. And so we estimate that to be around 500,000 developers. About 500,000 developers have given Solidity a go and decided not to do it for various reasons, either to do with risk or to do with complexity or to do with competence. So that's one of the big markets that we go after, because it's easy to convert them. You go, hey, you're a frustrated DeFi developer. You want to build something in DeFi. Here's a better tool to be able to do that. Here's how you can actually realize the thing that you've always wanted to build, but just felt like it would be too scary, risky, or problematic to do using Solidity. So we really go after those guys because that's a great market to move them off. And then your bottom right-hand quadrant is really where your biggest potential is. So everything like you have these highly competent developers who don't know that much about DeFi, but could easily move into it. So, all of the people working who are doing programming for investment banking, everyone in the back office who's doing code for Goldman Sachs and JP Morgan, who hire like hundreds of thousands of developers, everyone who's working at like a boring Web 2 SaaS financial application, like those guys, you can move up the DeFi competence curve very quickly. Also, that's where we see the high potential DeFi developers. That's also where we focus. And so our like sort of our marketing strategy, our attraction strategy on Scripto follows those 2 quadrants: A, frustrated DeFi developer, and B, high potential DeFi developer quadrant. And we've had a lot of success in that, right? The programming language went live. In test. The Scripto programming language went live in test at the end of 2020, and went through a sort of a 2-year period of beta testing. And in that 2-year period, we sort of Scripto downloads went from 0 to about 20,000 Scripto downloads, the Scripto repo. And our developer community, sort of active developer community within our Discord, sort of like continuously grew. And we got this sort of really great ground, and it was grassroots, because the point wasn't, hey, come in and build now, go launch now. It's like, hey, we've got an idea that we think is the right route to actually be building smart contracts on top of public ledgers. Come and get involved in helping formulate that. And that really was the sort of the starting point of building this grassroots movement of a true community that believed in the way that we were doing things and was engaged in doing that and helping us out and improving it. And that's sort of, I put a large degree of credit to why the documentation is so good, why Scripto as a programming language is so good. It just came from that work with the community over that 2-year period, which now leaves us to the point now where we have that core community who is super responsive. You come into the into the Discord channel and ask any question about Scripter, and instantly you get an answer from the community or from one of our own mods. But the community very often, highly supportive. Take people like Avant, like saw ERC 404 and went, I could do that in Scripter, no problem, then banged it out in a weekend. Like that is so important contextually around the programming language. Not just is your documentation good, but like, is the community supportive? Are people coming up with ideas? Are people reaching out? So yeah, that's the long and short of it.
Well, we covered a lot of topics, and I think we could probably talk for hours about all the differentiators between Radix and all the other choices developers have. Do you have any closing thoughts that you want to leave our listeners with as they would potentially want to get up to speed with this ecosystem, and potentially any resources that would be great for people who want to do a deeper dive?
Yeah, sure. So like, if you like the tech, then if you want to dive into the white papers, then go to radixdlt.com, and there's our white papers on there, including like sort of the peer-reviewed published one around our consensus algorithm. If you're interested in diving in as a developer, want to try it out, then docs.radixdlt.com is where our docs are. We pride ourselves on our docs, so please do go and check it out. It is very easy to get up and running. And then if you're interested from a user point of view, or like want to explore the ecosystem more, I highly recommend downloading the Radix wallet and just giving some of the apps in the ecosystem a try. My sort of top 3 recommendations are caviar9.com, which is a concentrated liquidity DEX on Radix. Super simple swapping interface, and like just use the DEX once on the Radix wallet to get what I'm talking about when it comes to user experience. You'll get to see human readable transactions. You'll get to see almost instant finality, like sub-second finality at the moment, and you'll get to sort of like feel what it means to be able to have an underlying ledger that where you understands all of the things that Radix engine offers. AussieSwap.com, which is an implementation just gone live of Uniswap v4 with all of the hooks. So it's a hooks-centric implementation of Uniswap v4 before Uniswap v4 has even been implemented on Ethereum. So if you're sort of a trading geek and you want to get into that, or you just want to be able to put on limit orders and things like that, AussieSwap v4 is great. AussieSwap v2, Uniswap v4 clone, is great for that. And then I'd also recommend checking out Trove, which is trove.tools, which is like an NFT trading platform. But the reason I'm recommending it is just got this really clean UI, really clean UX, and it sort of really meshes really nicely with the Radix wallet. So you get to sort of feel. Oh, and if you want to get some free Radix tokens to be able to do all of these things, then go to, when you download the wallet.radixdlt.com, you'll get invited to participate in something called Gumball Club, and Gumball Club will teach you how to use the wallet and also give you a couple of free tokens to then be able to access all of the other stuff on the Radix network.
Awesome. We're definitely excited to see what comes of Radix. Clearly, a lot of thought has been put into the architecture of this ecosystem. So super excited to see what's going to happen next. And thank you so much for taking the time and giving us the complete rundown.
Thank you. Thank you for having me.